We will tell you about light emitting diode. A light emitting diode LED is a two LED semiconductor light source. It is a PN junction diode which emits light when activated. When a suitable voltage is applied to the LEDs, electrons are able to recombine with electron holes within the device, releasing energy in the form of photons. Now, if we talk about the types of LEDs, there are four types of LEDs: bar graph, 7 segment, starburst, and dot matrix.
Now, if we come to the history of LEDs, electroluminescence as a phenomena was discovered in 1907 by the British experimenter H.J. Round of Marconi Labs using a crystal of silicon carbide and a cat's whisker detector.
As we can see in the figure, a light emitting diode consists of transparent plastic case, terminal pins, and a diode.
Now the question arises that how much energy does an LED emit? The energy of light emitted by an LED is related to the electric charge of an electron and the voltage required to the light of the LED by the expression which is given by E is equal to QV. This expression simply says that voltage is proportional to the electric energy and is a general statement which applies to any circuit as well as to LEDs. The constant Q is the electric charge of single electron, that is 1.6 into 10 to the power minus 9 coulomb.
Now, this is a typical LED block diagram which consists of battery power supply, LED driver, and switching control.
This diagram shows the analog LED drive circuit.
Working principle of an LED. The emission of light from a semiconductor under the influence of an electric field. The charge carries the charge carriers recombine in forward biased PN junction as the electrons crosses from the N region and recombine with the holes existing in the P region. Free electrons are in the conduction band of energy levels while holes are in the valence energy band. Thus, the energy level of the holes will be lesser than the energy levels of the electrons.
LEDs have wide range of applications such as in indicators and signs, lighting, data communication and other signaling, light sources for machine vision systems, and many other applications.
Now, if we talk about the first application of LEDs, that is indicators and signs, LED displays are used as stadium displays and as dynamic decorative displays. Thin, lightweight message displays are used at airports and railway stations and as LED destination displays for trains, buses, trams, and ferries.
LEDs are also used as light source for DLP projectors and to backlight LCD televisions and laptop displays. RGB LEDs raise the color gamut by as much as 45%. Screens for TV and computer displays can be made thinner using LEDs for backlighting. LEDs are used in data communication and other signaling. Light can be used to transmit data and analog signals. For example, lightning white LEDs can be used in systems assisting people to navigate in closed spaces while searching necessary rooms or objects. Machine vision systems often require bright and homogeneous illumination. Barcode scanners are the most common example of machine vision. Among the other applications, light emitting diodes, commonly called LEDs, are real unsung heroes in the electronics world. They do dozens of different jobs and are found in all kinds of devices. Among other things, they form number on digital clocks, transmit information from remote controls. Tied together, they can form images on a jumbo television screen or illuminate a traffic light. Basically, LEDs are just tiny light bulbs that fit easily into a electrical circuit. But unlike ordinary incandescent bulbs, they don't have a filament that will burn out and they don't get specially hot. They are illuminated solely by the movement of electrons in a semiconductor material and they last just as long as a standard transistor. The lifespan of an LED surpasses the short life of an incandescent bulb by thousands of hours. Tiny LEDs are already replacing the tubes that light up LCDs, HDTVs to make dramatically thinner televisions. LEDs can also be used for decoration purpose. Let's talk about working of LED. When sufficient voltage is applied to the chip across the leads of the LED, electrons can move easily in only one direction across the junction between the P and N regions. When a voltage is applied and the current starts to flow, electrons in the N region have sufficient energy to move across the junction into the P region. Definition: LEDs which could emit visible light, the band gap of the materials that we use must be in the region of visible wavelength 390 to 770 nanometer. This coincides with the energy value of 3.18 electron volt to 1.61 electron volt, which corresponds to the colors as stated below: violet, blue, green, yellow, orange, red. Electromagnetic spectrum: the appearance of the visible light will be the results of the overlap integral between the eye response curve and the spectral power of the device. The peak of the luminous curve will not in general be the same as the peak of the spectral power curve.